My dear students, welcome back to our channel. In this video, I will be explaining the Bachelor of Computer Applications second semester subject OOP with CEE as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1, the important short question is 1. What is OOP? OOP, Object-Oriented Programming, is a method of writing programs by using objects, which are based on real-life things. Objects have data, called attributes, and functions, called methods, that work on the data. OOP makes coding easier to understand, reuse, and manage, especially for big projects. Key features of OOP. 1. Class, a template or blueprint, example, student. 2. Object, a real example of a class, example, Ram, who is a student. 3. Encapsulation, hiding data using access rules. 4. Inheritance, one class can get features of another. 5. Polymorphism, one task done in many ways. Example. Class car. Public. Void start. Count car started. Easy to remember. OOP is equal to think like real life. It helps you solve problems in code just like how you deal with things in the real world. Next important short question is 2. What is namespace in C++? A namespace in C++ is like a folder that holds your code to avoid name conflicts. When two programmers use the same variable or function names, namespaces help keep them separate and organized. Why use namespace? To prevent confusion when different parts of a program have same names for variables, functions, or classes. Example. Hush include iostream. Using namespace std. Namespace school. Void show. Count welcome to school. Namespace college. Void show. Count welcome to college. int main. School show calls school version. College show calls college version. Return 0. Here both school and college have a show function, but they don't clash because they are in different namespaces. Easy to remember. Namespace is equal to name folder. It keeps code neat and prevents name fights in big projects. Want to learn about std and how it's a common namespace in C++? Next important short question is 3. What are keywords in C++? Keywords in C++ are special reserved words that have a fixed meaning in the language. You cannot use them as variable names because C++ uses them to understand what your program is doing. Why are they important? They are the building blocks of C++ programs. Each keyword has a specific job, like creating loops, functions, or conditions. Examples of C++ keywords. int to declare an integer. Float for decimal numbers. If-else for decision making. For, while for loops. Class to define a class used in OOP. Return to return a value from a function. Void means no return value. Public, private used in OOP for access control. Example. int age is equal to 18. If age is equal to 18. Count you are an adult. Easy to remember. Keywords is equal to C++'s own language. They are like grammar rules in English. You must follow them to write correct programs. Next important short question is 4. What are identifiers in C++? Identifiers are the names you give to things in your C++ program like variables, functions, classes, objects, etc. They help you identify and use different parts of your code. Example of identifiers. Int age is equal to 18. Float marks is equal to 85.5. Void showMessage. Count hello. Here, age, marks, and showMessage are identifiers. Rules for writing identifiers. 1. Can use letters, AZ, digits, 0 to 9, and underscore. 2. Cannot start with a digit. 3. No spaces or special symbols like @ hash, etc. 4. Cannot use C++ keywords like int, if, class as identifiers. Easy to remember. Identifiers is equal to your own names in code. Just like you have a name to identify you, identifiers give names to parts of your program. Good identifiers make your code clean and easy to understand. Next important short question is 5. What is dynamic initialization of variables in C++? Dynamic initialization means giving a value to a variable at runtime, not at the time of writing the code. The value is calculated when the program is running, using input, function results, or expressions. Why use it? Sometimes, we don't know the value at the start. We need to calculate it while the program is running. That's when dynamic initialization is useful. Example. Hash include iostream. Using namespace std. int main. int a is equal to 10. int b is equal to 20. int sum is equal to a plus b, dynamically initialized using expression. Count sum is sum. Return 0. Here, sum is dynamically initialized using the values of a and b during runtime. Easy to remember. Dynamic is equal to value decided while running. It's useful when the value depends on user input, formulas, or function results. Next important short question is 6. What are reference variables in C++? A reference variable is like a nickname or alias for another variable. It does not create a new memory space, it just refers to the original variable. Why use reference variables? They are useful when you want to pass values to functions without copying or change the original variable from inside a function. Example. Hash include iostream. Using namespace std. int main. int x is equal to 10. int and ref is equal to x, ref is a reference to x. Ref is equal to 20, changes x to. Count x is equal to x, output, x is equal to 20. Return 0. Here, ref is just another name for x, changing ref also changes x. Easy to remember. Reference is equal to real variable's nickname. It points to the same memory location, making it helpful in functions and performance-friendly. Next. Unit 2 Important Long Questions. First important long question is: differentiate between procedure-oriented programming and object-oriented programming features. Here's a simple and easy-to-remember comparison table between procedure-oriented programming (POP) and object-oriented programming (OOP). Feature procedure-oriented programming (POP), object-oriented programming (OOP). Focus functions procedures objects, data plus functions. Structure divided into functions divided into classes and objects. Data access global data shared by all functions. Data is hidden inside objects, encapsulation. Security less secure, any function can access data, more secure, access is controlled. Code reusability difficult to reuse code, easy to reuse using inheritance. Real-world mapping hard to map real-world problems, easy to model real-life things as objects. Example language C, C++, Java, Python with OOP. Ease of maintenance difficult in large programs, easier to manage and update. Data movement. Data moves openly between functions. Data stays inside objects and is accessed safely. Tip to remember. OP is equal to step-by-step recipe. OP is equal to box with data and tools inside. Let me know if you want a printable version or quiz to revise this. Next important long question is: to write about benefits and applications of OOP. Benefits and applications of OOP, object-oriented programming. Benefits of OOP. 1. Real-world modeling. OOP lets you create programs that work like real-life things. Example, a car object can have properties, speed, color, and actions, drive, stop. 2. Code reusability. Using inheritance, we can reuse existing code in new programs. Example, a class bike can use features of a vehicle class. 3. Data security. With encapsulation, data is kept safe inside objects. Only allowed functions can access or change it. 4. Easy maintenance. If there is an error, you can fix it in one class without changing the whole program. 5. Flexibility with polymorphism. You can write one function that works in different ways for different objects. Example, a function draw can draw a circle, square, or triangle depending on the object. 6. Better productivity. OOP makes programming faster, especially in large teams and big projects. Applications of OOP. 1. Software development. Used in making modern software like MS Word, Photoshop, etc. 2. Game development. Objects like player, enemy, level, and weapon are used in games like PUBG, Free Fire, etc. 3. Web applications. Websites like Amazon, Facebook, and YouTube use OOP concepts to manage user data and features. 4. Mobile apps. Android and iOS apps are built using OOP languages like Java, Kotlin, Swift, etc. 5. Banking systems. Customer, account, transaction, all are objects. OOP keeps data secure and easy to manage. Easy to remember. OOP is equal to secure plus reusable plus real-world plus easy to manage. OOP is not just a coding method, it's a smarter way to solve problems by thinking like real life. Next important long question is: 3. Structure of C++ program, explain with an example program. Structure of a C++ program. A C++ program is made up of different sections that work together to perform specific tasks. Understanding its structure is the first step to writing clean and organized code. Basic structure of a C++ program. 1. Preprocessor directives. These are instructions to the compiler before the actual program begins. They start with a hash symbol. Example. 2. Hash include IOStream includes the input-output library. The most common preprocessor directive is hash include, which adds libraries or other files to the program. 3. Namespace declaration. C++ uses namespaces to organize code. The most commonly used one is std, standard. Example. 4. Using namespace std, this allows us to use the standard library without prefixing std. 5. Main function. Every C++ program starts with the main function. It's the entry point where the program begins execution. Example. 6. int main. 7. Code inside the main function. 8. Return 0, ends the program. 9. 10. Variable declarations. Inside the main function, you declare variables to store data such as int, float, char, etc. Example: 11 int num is equal to 10. 12 float price is equal to 5.99. 13 statements and expressions. These are the actions that the program performs, like calculations or printing results. Example: 14 count hello world prints a message to the screen. 15 return statement. This statement ends the main function and returns a value, usually 0, indicating the program has run successfully. Example: 16 return 0 success. Full example of a simple C++ program. Hush include IOStream include input-output library. Using namespace std, use standard library. int main function starts here. int num is equal to 10, declare a variable. Count the value of num is num_ndl, print the variable. Return 0, end the program. Easy to remember. Preprocessor namespace main code return. By following this structure, you can easily write, read, and understand C++ programs. Next important long question is: 4 basic, derived, and user-defined data types in C++. Basic, derived, and user-defined data types in C++. In C++, data types are used to specify the type of data a variable can hold. There are 3 main types of data types: basic, derived, and user-defined. 1. Basic data types. These are the simple data types that C++ provides directly. They store simple values like numbers, characters, and more. int for storing integers, whole numbers. Example: int age is equal to 20. Float for storing decimal numbers, single precision. Example: float price is equal to 99.99. Double for storing large decimal numbers, double precision. Example: double distance is equal to 10.5. Char for storing single characters. Example: char grade is equal to A. Bool for storing Boolean values, true or false. Example: bool is student is equal to true. 2. Derived data types. These data types are derived from basic data types. They are used to store more complex data structures. Arrays, a collection of similar data types. Example: int scores 5 is equal to 85, 90, 78, 88, 92. Pointers, a variable that stores the memory address of another variable. Example: int a is equal to 10. int asterisk ptr is equal to and a. References, another name for an existing variable. Example: int a is equal to 10. int and ref is equal to a. 3. User-defined data types. These are data types that you can create based on your needs. They allow you to combine multiple data types into one, making your code more structured and easier to manage. Structures, struct, used to combine different data types into one unit. Example: struct student, int roll no, string name, float marks. Student S1 is equal to 101, Ravi 85.5. Unions similar to structures, but all members share the same memory. Example: union data, int I, float f. Classes used in object-oriented programming, OOP, to define objects with properties and methods. Example: class car, public, string brand, void drive, count car is driving. Easy to remember. Basic types is equal to simple data, int, float, char. Derived types is equal to built from basic, arrays, pointers. User-defined is equal to your custom types, structs, classes. Understanding these data types will help you manage and organize data more effectively in C++ programs. Next important long question is 5. What is storage class and its types? What is a storage class in C++? In C++, a storage class defines the lifetime, visibility, and location of a variable. It tells the compiler how and where to store the variable and how long it should exist. This helps control the memory and behavior of the program. Types of storage classes in C++. 1. Automatic, auto. Default storage class for local variables. Variables are created when the block or function starts and are destroyed when it ends. Local variables in functions are auto by default. You don't need to write auto explicitly. Example. Void example. int num is equal to 5, num is auto by default. 2. Register, register. Variables are stored in the CPU registers for faster access instead of RAM. Only simple data types like int can be declared with register. The variable's memory location can't be accessed, no AND operator allowed. Example. Register int speed is equal to 60. Speed will be stored in a CPU register. 3. Static, static. Variables are preserved between function calls, meaning they retain their values even after the function ends. The variable is stored in memory for the lifetime of the program. Example. Void count calls. Static int counter is equal to 0. Counter plus plus. Count function called counter times. 4. External, extern. Used to declare variables that are defined outside the current file or function. It tells the compiler that the variable exists elsewhere and prevents redeclaration. Used to access global variables in multiple files. Example. Extern int total, total is defined in another file. 5. Mutable, mutable. Used with class data members to allow modification of the member variable even if the object is const. It's useful when you want a class member to be modifiable while maintaining the overall constness of the object. Example. Class counter. Public. Mutable int count. Counter, count, 0. Easy to remember. Auto is equal to local, temporary variables. Register is equal to for faster access, CPU memory. Static is equal to remember values across function calls. Extern is equal to share variables across files. Mutable is equal to modify even in constant objects. Understanding storage classes helps you manage memory and control the behavior of your variables, making your programs more efficient and organized. Next important long question is 6. Describe about memory management operators in C++. Memory management operators in C++. In C++, memory management is crucial for controlling how memory is allocated, given, and freed, released during program execution. C++ provides memory management operators to handle dynamic memory allocation. These operators allow us to allocate and deallocate memory during runtime, making the program more efficient and flexible. Memory management operators in C++. 1. New operator. The new operator is used to dynamically allocate memory for variables during the program's execution. It returns a pointer to the allocated memory. This memory must be freed manually using delete when it is no longer needed. Example. int asterisk ptr is equal to new int dynamically allocates memory for one integer. ptr is equal to 10, assign value to dynamically allocated memory. Count asterisk ptr, output 10. 2. Delete operator. The delete operator is used to free the dynamically allocated memory. It delocates the memory that was previously allocated with new. Always remember to use delete to avoid memory leaks, unused memory that isn't freed. Example. Delete ptr frees the memory that ptr was pointing to. 3. New operator. The new operator is used to allocate memory for an array of objects or variables. It returns a pointer to the first element of the array. Example. int asterisk ar is equal to new int 5 dynamically allocate an array of 5 integers. ar0 is equal to 10. ar1 is equal to 20. Count ar0 output 10. 4. Delete operator. The delete operator is used to deallocate memory allocated with new for an array. It helps in cleaning up memory after an array is no longer needed. Example. Delete ar frees the array memory allocated using new. Important points to remember. New is equal to allocate memory, single variable or array. Delete is equal to free memory allocated for a single variable. New is equal to allocate memory for an array. Delete is equal to free memory allocated for an array. Easy to remember. New for allocation. Delete for deallocation. New for arrays. Delete for array deallocation. Final thought. Using memory management operators properly is essential for efficient programming in C++. It helps to avoid memory leaks and ensures that the program uses memory only when required. I hope you understand easily each question. All the best, students, for your upcoming exam. For other subject quick revision. Important questions. Previous question papers. And syllabus. Links are available in description. Check out once. Thank you for watching. Like and share this video with your friends.